Good day everyone, in this video I am going to talk about Kepler's 3 laws of planetary motion. In the early 1600s, Johannes Kepler proposed 3 laws of planetary motion. Kepler was able to summarize the carefully collected of his data of his mentor Tycho Brahe with 3 statements that describe the motion of planets in a sun-centered solar system. Kepler's efforts to explain the underlying reasons for such motions are no longer accepted. Nonetheless, the actual laws themselves are still considered an accurate description of the motion of any planet and any satellite. Kepler's 3 laws of motion are the following. First, the Law of Ellipses, that describes the path of the planets about the Sun is elliptical in shape, with the center of the Sun being located at one focus. Second, the Law of Equal Areas, an imaginary line drawn from the center of the Sun to the center of the planet will sweep out equal areas in equal intervals of time. Third, the Law of Harmonies, or the ratio of the squares of the periods of any 2 planets is equal to the ratio of the cubes of their average distances from the Sun. Kepler's first law, sometimes referred to as the Law of Ellipses, explains that planets are orbiting the Sun in a path described as an ellipse. An ellipse is a special curve in which the sum of the distances from every point on the curve to 2 other points is a constant. The 2 other points are known as the foci of the ellipse. The closer together that these points are, the more closely that the ellipse resembles the shape of a circle. In fact, a circle is the special case of an ellipse, in which the 2 foci are at the same location. Kepler's first law is rather simple. All planets orbit the Sun in a path that resembles an ellipse, with the Sun being located at one of the foci of that ellipse. Kepler's second law, sometimes referred to as the Law of Equal Areas, describes the speed at which any given planet will move while orbiting the Sun. The speed at which any planet moves through space is constantly changing. A planet moves fastest when it is closest to the Sun and slowest when it is furthest from the Sun. Yet, if an imaginary line were drawn from the center of the planet to the center of the Sun, that line would sweep out the same area in equal periods of time. For instance, if an imaginary line were drawn from the Earth to the Sun, then the area swept out by the line in every 31-day month would be the same. The areas formed when the Earth is closest to the Sun can be approximated as a wide but short triangle, whereas the areas formed when the Earth is farthest from the Sun can be approximated as a narrow but long triangle. These areas are the same size. Since the base of these triangles are shortest when the Earth is farthest from the Sun, the Earth would have to be moving more slowly in order for this imaginary area to be the same size as when the Earth is closest to the Sun. Kepler's third law, sometimes referred to as the Law of Harmonies, compares the orbital period and radius of orbit of a planet to those of other planets. Unlike Kepler's first and second laws that describe the motion characteristics of a single planet, the third law makes a comparison between the motion characteristics of different planets. The comparison being made is that the ratio of the squares of the periods of the cubes of their average distances from the Sun is the same for every one of the planets. Kepler's third law provides an accurate description of the period and distance for a planet's orbits around the Sun. This has been Adasa, and thank you for watching.